แต่ว่าเปิดตัวสารคอมเลยเนี่ยสอบใช่ใช่อะไรมันติดเทียบตัวติดตัวแปดของครับตัวดีอ่ะดีดีคำนวณจากเดลต้าหารด้วยซิกมาเราใช้กราฟก็ได้ในการคำนวณในการ You have to carefully check the problem statement because you can use the graph, you can use minitab, you can use by calculation by equation. Because the graph we know we know beta, you can estimate n from the curve. Okay, we record already. For the next topic, as I previously talked about the mean. And the next topic, we would like to check the variance or standard deviation. Like the variance or standard deviation. For this, you test on the variance is equal or not equal. Then, อาจารย์พูดเรื่องนี้อยู่ใช่ไหมงงเลยเริ่มงงเริ่มมึน Okay, we talk about the hypothesis test. That's right. Okay, hypothesis test for one simple. Okay. You would like to check your variance is equal to spec or not, to spec or not to standard. But at the top to you, if we consider the variance, we will use the sine square test, not C test, not T test. We use the sine square for the variance. Like we use this square, and the equation defined by this test. Defined by this test. It's calculated n minus one sample value divided by the standard or sigma zero. And also if it's two-side test, this is will reject like upper and lower one. I think I have shown this. We conclude in this slide. This is for two-side test. This is the lower one. This is the upper one. If the sine square value is located in this we reject x0. x0 xy is the same. Equal, not equal, equal greater than, equal less than. It is the same. And for this case, the upper, this is the lower. This is another case. This is greater than, or this is less than. But for this case, we consider sigma square or variance. But previously we talked about the mean. The mean we use C and T case. For variance we use sine square case. For this example, we consider the automatic machine for filling the detergent that how to use previously. We land on something the data with something about 20 bottles, 20 bottles. And for this case, you measure the variance of filling volume. The variance of filling volume is 0.015. If the variance of filling volume exceeds 0.01 and an acceptable proportion of bottle will be undefined or overdefined. If the evidence in the sample data suggests that manufacturing has a problem with underfill or overfill bottle. Underfill or overfill bottle. For instance, we check with greater than the value is greater than 0.01. Because it's value greater than 0.01. Is the error. It's less than 0.1, okay, you accept. The error is maybe positive or negative, but we use variance. It means sigma square. That is positive one. Okay, we would like to check the frequency is greater than or equal to 0.0. At the top of you, we calculate sigma standard deviation. Standard deviation indicates the area of your data. Area of your data. It's large or small area. For this case, we use We use chi square as a statistic. We calculate chi square with n minus 1 s square is the variance of sample. That's right. Variance of sample is equal to this. This is very example. And this is the standard, right? That we would like to take it 0.01. This is hypothesis variance 0.01. Okay, we will reject x0 if sin square 0 greater than sin square 0.05. This is alpha, 95%. And degree of freedom is n minus 1. It's 90. You get 30.1. If sin square 0 greater than this, you will reject x0. If sin square 0 less than this, you will accept x0. Right? Okay, you calculate sin square 0 by substitute n, substitute s square, substitute sigma 0. You get 29.07. It's less than what does it mean? You accept x0. Right? Accept x0. That means you can conclude that there is no strong evidence or the volume field is not exceed 0.01. That's not exceed 0.01. If you read it, it's quite confused. There is no strong evidence that variance of field volume exceed 0.01. ก็คือไม่ได้มีหลักฐานชัดเจนว่ามันมากกว่าคำตอบก็เป็นน้อยกว่าภาษาอังกฤษต้องการ You have to translate it. We conclude that there is no strong evidence to conclude that the variance exceeds 0.1. ไม่ได้มีหลักฐานที่แข็งแรงพอที่จะบอกว่ามันมากกว่าเราก็รู้สึกว่าน้อยกว่า because we accept. That's why we conclude that the variance is less than 0.6. It's good, that's right. Because the error is low. It's lower than 0.2. ก็คือเรื่องมันก็น้อยก็ดีนะครับ Okay. And also we can use this by Excel. Sorry, Minitab. Minitab. You use the basic scientific and go to what I know. Okay. Variant. We use statistic and basic. For this case, we have the variant. We have the variant, one variant and two variant. For this case, one variant. We choose one variant. And if you have the data in spreadsheet, you can choose this. Right. Okay, you can choose, sample standard deviation or sample, but you can use both. Sample standard deviation is S. Sample value is S square. Yes, you can use both of it. For this case, I use sample value. Okay, sample value which you give. Sample size is 20, right? Okay. And the sample value is 0.0153. We would like to perform hypothesis. That's right. Perform means do or include. Hypothesis test. Hypothesis standard deviation is 0.01, right? We want to get this value, 0.01. Okay, and then the quick option. The option is alpha 0.05 or 95%. Right? It's 95%. And x0 equal but s1. For this case, we not necessarily to choose x0 because x0 fixed is equal. That's right. You found that on many tabs that I showed you, you only choose the alternative hypothesis for s1. Because in the program, fix s0 is equal or less. That's right, equal or less. Okay, we have three choices, S1. For this case, it's greater than standard deviation. It's greater than hypothesis standard deviation. You don't worry, for this case, we choose sample variant or sample standard deviation. The program will be transferred between two values for you. Okay, sorry for this. We should be proper. Because we should variant, not standard deviation. But we have to try standard deviation or variant. Because we should variant from this. 0.01. An option variance greater than hypothesis. Okay, and then it is okay, and okay, and the data is summarized in this video. We test based on CI for one variant. The new hypothesis equal or relative hypothesis greater than S0, S1. We use the sign square. Right, for this we have some comment sign square method is only for normal distribution. Right. And certificate is summarized n equal to 20. That's right. Standard deviation is 0.124. Variant, you input variant, it calculates standard deviation for you. And also show the 95% confidence interval. Right. This is the lower bound for standard deviation. This is the lower bound for variant. That's right. And this is the conclusion about p-value and test statistic. The p-value is greater than alpha, right? 0.065. You accept. And also the variant is 0.0096. Our element is 0.01. That's right. It's less than 0.01. You accept also. That's right. You accept also. Okay, for this case. That means the variant is less than 0.01. Okay, for this for the variant, I will show you only one. Okay, for the next one we talk about the large sample for proportion test. Proportion test is usually we talk about the defect or defect. We say not equal and not equal. But for proportional test, if the large sample we use C test. We use C test and we define the C distribution or test statistic. We define the test statistic. This value, and also we know the P0 n number of samples like this. And also if for two-side test, we use this to reject. Okay, for this example, we show you the semiconductor produced by automobile engine that the customer requires that the process form out of fraction defect. If not exceed 0.05. This is the spec. The spec of the customer is the defect is not exceed 0.05. So the proportion. By proportion, because it is fraction defect. That's right, fraction defect. If you collect sample and you count the number of defects, that's right, number of defects divided by the total number that this is the fraction. The fraction defective not exceed 0.05. That means not exceed 5%. The fraction 0.05 means 5%. Okay, for this case, the company sampling 200 of semiconductor, right? 200 of semiconductor and found that 4 of them are defect. Right? 4 of them are defect. And the manufacturer demonstrate process capability for the customer. You have to confirm this is meet the requirement of customer or not. That's right. Your production. That's right. You collect 200 samples and then you found 4 samples is defect. And also you have to conclude this defect or this process meet the requirement. The requirement is the customer requirement. Is 0.05. Okay, for this case, we would like to get the proportion is equal or less than 0.05. That's right. Less than 0.05. Okay, for this case, we use alpha 0.05, you use the C test, x minus n p0. For this case, x equal to 4. Number of defects is 4. Total number is 200. And we would like to the hypothesis P is equal to 0.05. That's right. P P0 is equal to 2 watt per kilowatt. And this is for the C region is minus 1.64. This is the lower bound, the cytochrome less than. This is the critical region. Like if you plot the curve, you see reject region is minus 1.645. And then you calculate C0, right? You substitute X4 and 200 P0.05. Right? You get minus 1.95, right? 1.95 for this. And 1.95 is less than minus 1.645. That you reject X0. You accept S1. Right? You accept S1. That means we conclude that the process fraction defective less than 0.05. That's right. That means meet the requirement. Okay. Because the customer needs not exceed 0.05, but you conclude that it's less than 0.5. Okay, that's correct. Meet the requirement of customer. That's right. Meet the requirement of customer. Because the customer needs not exceed 0.05, not greater than 0.05. It should be less than 0.05. And then you found that you reject S0. You accept S1 less than 0.05. Okay. We conclude that if 4 defect from 200 something this is meet the requirement of customer. That's right. When you produce, it may be defect, but customer accept 0.05. That's right, 0.05 in the percent fraction. Because we calculate on fraction defective in terms of proportion. Okay, for this. In Minicap also we use the proportion, right? We have the proportion in Minicap. Statistic basic also we go to this is the proportion. Proportion we have one proportion and two proportion. One proportion is one sample. We go to one proportion. And also if we have some data, right? For this case we use the summarize data. Number of events for this mean the number of defects. Okay. 4. Number of trials is the total number that you sample. 200. And we would like to perform hypothesis test. The hypothesis proportion is 0.05. Right? That means S0 equal to 0.05. And then you take alternative for it. You take based on 95% or alpha 0.05. You take based on proportion less than hypothesis proportion. But for this, we use the normal approximation. Okay. And this is summarized based on S and CI for one proportion. P equal or P less than. P equal or P less than. And then we summarize the data. Your defect is 4, number is 200. The sampling proportion is 0.02, right? 0.02 because 4 divided by 200. This is 4 divided by 200. And 95% upper bar is 0.03. Right? Set value of P value. P value is 0.025. Less than 0.05. That's right. It's less than 0.05. You reject. You accept for this. Okay. And the proportion for this is 0.03. Compared to 0.05. It's less than, right? It's less than. Okay. For this case, we get the upper bound. Right? Okay. For this case, the strong conclusion that the defect is less than the fraction of 0.05. That means your production is meet the requirement. Meet the requirement. This is we show you for the simple exercise for one simple exercise for one simple. For the next time, maybe I would like to talk to you to compare between